Next few reactions are pretty quick. One is called the hydration. I'm not going to go over any of these mechanisms, but you'll kind of see. I'm going to go over through them pretty quick. You can put these on your card. Again, ketone or aldehyde. You're going to be adding water as your nucleophile in the presence of acid, and you form this compound. All right, you get two OH groups. 9.8 is where you add alcohol. And same thing, ketone and aldehyde, ketone or aldehyde. You're going to add an alcohol. In your books, since I can't do colors, what they usually do is have this prime symbol. It's like a prime, R prime. That kind of tells you that this R group that has the prime is not the same as the other R groups on your molecule. You actually have to add two equivalents of this. And you form what's called an acetal. Acetals are pretty important in sugar chemistry, in biochemistry. So if you go on to take biochemistry, you'll learn all about acetals. There's also something called a hemiacetal, which is where one equivalent of water and one equivalent of alcohol add to your ketone or aldehyde. And what you get with hemiacetal, meaning half of it is acetal. All right, this doesn't mean hemi as in a big engine, in a car or something. It's a half and half. You got half OH and half OR. In sugar chemistry, you'll see a sugar like this with an OH right here. You guys have probably seen these as the classic example of a sugar. OH, OH, OH. This right here is the hemiacetal. You have a carbon right here that's attached to an oxygen that's attached to a carbon. All right, so, and then you have an OH attached to it. So here's your OH part of it, and here's your O attached to your R. Okay, so you see these a lot in sugar chemistry. So those of you going to take biochemistry, you're going to see hemiacetals quite a bit. All right, 9.9 is imines. It's pronounced imine. It's like a ketone, but instead of having an oxygen, you have a nitrogen. That is an imine. All right, the way you make it is you start with either an aldehyde or ketone. Again, it doesn't matter. I guess I should put an H here just to be complete. And you add, it's got to be a primary alcohol. All right, I'm sorry, a primary amine, meaning your nitrogen is attached to one R group. Okay, and then you add acid. The reason is because you lose an equivalent of water, and the water comes from these two hydrogens and this oxygen. So in order to lose water, you have to have at least two hydrogens on there. Let's put a prime there so it distinguishes between the groups. H. Right, and those are imines. The last reaction in this chapter is called the conjugate addition. This is what's called a 1,4 addition. All right, up until now, we have been doing what's called a 1,2 addition. Okay, I'll show you what that means. So, actually, let me do a cyclohexane. It doesn't have to be a cyclohexane, but I'm just going to show you. The way you count this, so this 1, 2, 1, 4 has nothing to do with how you count, how you name something. Basically, the 1 is always your oxygen. Then the carbon next to that is the 2, and then the carbon next to that is the 3, and then the carbon next to that is the 4. We have been doing 1, 2 additions. So if I were to add a Grignard to this, these do 1, 2 additions. It adds to the second atom in our numbering system. Again, let's make that a prime. All right, it adds to this carbon. This Grignard adds to carbon 2. Okay, 1,4 additions, you have to have what's called 1,4 additions. You have to have a compound that's called an alpha beta unsaturated ketone or aldehyde. I'll just put ketone for right now, but just remember, whatever you do to a ketone, you can do to an aldehyde. I'm not going to write aldehyde, but just know that you can do it. Okay, so a 1-alpha-beta unsaturated ketone, what is that? It's a ketone where at the alpha carbon and the beta carbon, this is the alpha carbon and this is the beta carbon, you have an unsaturation, you have a double bond. Okay, and then if you add weak nucleophiles, remember the weak nucleophiles are the ones that are protonated. So like if you add, let's say, an alcohol, CH3OH. The strong version would be CH3O negative. All right, but this is the weak version. All right, you do this in acid, and the numbering system, 1, 2, 3, 4. This is a 1,4 addition, so your oxygen adds to the 4th carbon rather than to carbon number 2. I know this might seem confusing. It really isn't. Don't make it harder than it seems. If you have a strong nucleophile, like a Grignard, has a negative charge, it goes 1, 2. Strong nucleophiles go 1, 2. Strong nukes go 1, 2. Weak nucleophiles go 1, 4. Weak nukes go 1, 4. Okay. Read about this in the book. If there's questions, we can go over it in class. I can go over mechanism if you'd like. It's not you're not responsible for a mechanism, but this is basically it. Depending on the type of nucleophile, either goes 1, 2, or 1, 4. Okay, so let me just kind of restate this. Let's say you have an alpha beta unsaturated and you add a Grignard to it. So you have an unsaturated alpha beta ketone and you're adding a Grignard. Grignard is a strong nucleophile, so it goes 1, 2. It does not touch the double bond on the ring. Okay, your second step is adding acid. If you have the alpha beta unsaturated ketone and you add, let's say, an amine, let's say you add a nitrogen compound, let's say RR, at least one hydrogen. Well, is this a weak nucleophile or a strong nucleophile? Remember, the way you tell, it's very easy. Is there a negative charge on your molecule? A full negative, not a partial negative. You have to have a partial negative at least. Well, there isn't. This is a neutral or partial negative nitrogen. So it's going to go 1, 4. Sorry for the sniffles. I have a cold today. So you get the 1, 4 addition and you get rid of that pi bond. So if you're trying to determine if it's going to go 1, 4 or 1, 2, look at your nucleophile. If it's a strong nucleophile, it goes 1, 2. If it's a weak nucleophile, it goes 1, 4.